Hello everyone. In this video, we'll be dealing with what is meant by torque or moment of force. Okay, torque or moment of force. So just before discussing what is meant by torque or moment of force, just think about one object is placed here. Okay, an irregular shaped object is here. Just imagine this is the point where an entire mass of the body is supposed to be concentrated. That is called what? Center of mass. So this is the center of mass. Now you just imagine you are applying a force on the center of mass. Okay, it should be straight line. If you are applying a force on the center of mass, what will happen to this body? Definitely you can say that the body will now move in the same direction of the applied force. Okay, that means whenever you are applying the force on the center of mass of the body will go in the same direction of the applied force. Okay, that means here the motion we can say that is the translatory motion. Okay, the body is now moving, we can say that word translatory motion. Now you just imagine the same body, okay, an irregular shaped body. Okay, this is the center of mass, you consider this is the center of mass. Now you just imagine you are applying a force on the body, not in exactly in center of mass, some other end here. You can see here, this is the applied force. What will happen to the body? You can do with a one object here. You can see instead of translatory motion, the body now started rotating. The body now started rotating, and this is called torque. That means whenever you are applying a force, if the body start rotating, this is called what? Torque. The torque basic formula we use to represent the torque as tau. Okay, tau. So torque tau is equal to force into perpendicular distance. Force into perpendicular distance. This is the basic formula. So what is meant by perpendicular distance? Just imagine you are applying the force on this body in this direction. Okay, it should be straight line. So when the force is applied, imagine the body is now rotating about this axis. Okay, we are considering here the body is now rotating about this axis. Okay, this is the way the body is now rotating when you are applying this force. Okay, if you draw a perpendicular to the force, so this is the case, you are drawing a perpendicular to the force, so this angle become 90 degree, and from the O to the point of application of force, this is the point of application of force, so this can be taken as D, the perpendicular distance, and force is already shown here, capital F. So torque can be written as torque tau is equal to force into the perpendicular distance is D. So this is called what? Torque. That means a force which you applied makes the body rotate, and that is called what? Torque. And the basic formula for torque is what? Torque is equal to force into perpendicular distance. Now we have to discuss the same equation in terms of vector notation. So let's discuss about this one in terms of vector notation. So how to represent the torque in vector notation? So to explain that, just to consider three axes. This is the z axis. Okay, this is the y axis, or say it as x axis, and this is the y axis. Okay, consider a particle. This is the particle, say it as the particle P. Okay, one is applying a force on this particle. Say it as you are applying a force on this particle like this in this direction. Okay, this is the direction of applied force on the particle. You can see the force is now in which plane? XY plane. Okay, it is in the XY plane. Now how to draw the position vector? This is the origin O, right? So if you draw the position vector from O to the point P, that can be written as R vector. Position vector is R vector. Okay. Now if you extend this force, just extend this force backward, and if you draw a perpendicular from the origin, just to draw a perpendicular, this is the perpendicular distance. Okay, perpendicular distance. Now you extend this position vector. This is the position vector, right? So if you extend this line, you can consider this is the position vector, and this is the angle theta. What is angle theta? Theta is the angle between position vector and the force vector. So torque can be written as in terms of vector notation. Tau is equal to R cross F. Tau is equal to R cross F. That means tau is equal to RF sine theta. Where what is theta? Theta is the angle between force vector and the R vector. Clear? And definitely this angle is equal to what? That is equal to 90 degree, right? So if this is the angle theta, this angle also become theta. That is, if you consider this triangle, say it as this is N, consider the triangle ONP. P is the position of particle, right? If you consider triangle ONP, we can calculate from the sine theta is equal to opposite side, that is ON, divided by hypotenuse. Hypotenuse means what? OP. So sine theta is equal to ON is D, OP is equal to R. So we can write here D is equal to R sine theta. If you substitute this equation D value in this one, we can, if you substitute this value here, we can write here tau is equal to RF sine theta. Here R sine theta is equal to D. D is the perpendicular distance, right? So we can write here what? Tau is equal to F into D. This is a magnitude. F into D. So this also can be written as torque is equal to what? Force into perpendicular distance, or we can use in vector notation board tau is equal to RF sine theta. RF sine theta. So now next question, what is the direction of torque? In order to find the direction of torque, okay, there are two methods are there. One is screw rule, other one is the right hand thumb rule. Let's use the first one, that is the screw rule. Consider this is a screw and this is a screw head, okay. Now, in which direction you have to rotate the screw head? From R to F. You see this one? R to F, because the formula is R cross F. Now you are rotating the screw from R to F. That means in the direction of anti-clockwise direction. In this case, in which direction the screw will now advance? The tip of the screw will advance upward. That means here the direction of torque will be upward direction. That means perpendicular to the plane containing the position vector and the force vector. Or if you use the right hand thumb rule, okay, use your right hand thumb rule everyone now. Curl your fingers from R to F. Curl your fingers, okay, curl your fingers from R to F. Now what is the direction of thumb represents? The direction of thumb represents upward. That means perpendicular to the XY plane, and that is the direction of torque. Okay, and that is the direction of torque. So torque direction will be perpendicular to the XY plane. That is in the picture you can see that is along the Z axis. So this is a way to represent what? Torque in vector notation. Now let's discuss about a few cases. Okay, say it as case 1. In case 1 we are discussing here when R is equal to 0. When R is equal to 0, what is the torque? Torque is equal to RF sine theta, right? If R is equal to 0, we can say that torque is also equal to 0. Just an example, consider a door, okay? Consider a door. This is the door and this is the point where we will be keeping the handle, okay. Always we will be keeping the handle at this position. Now you just imagine this is the hinges, and hinges is considered as the axis of rotation, right? Axis of rotation. So this is the origin you can consider. Just imagine if you are applying the force at this point, can you open the door? You cannot open the door in this case, right? Here in this case R is equal to 0. We are considering R is equal to 0 because you are applying, or the point of application of force in the axis itself. So we can consider here the door won't rotate, or the torque is equal to 0. Okay. Now let's discuss about case 2. In case 2 we'll be dealing with when theta is equal to 0 or theta is equal to 180 degree. Theta is equal to 0 or theta is equal to 180 degree. The same example you can consider here. When theta is equal to 0 mean what? Torque is equal to RF sine 0, or torque is equal to RF sine, the angle is 180. Okay. Theta is equal to 0 or 180. Torque is equal to what? 0 itself. Torque is equal to 0 itself. That means you can see here theta is the angle between position vector and the force vector, right? If both are acting in the same direction, what will happen? There won't be any torque here. So that is the case 2. Now let's discuss about the case 3. Okay, case 3. When theta is equal to 90 degree, that means the force vector and the position vector both are acting exactly perpendicular to each other. We can say here tau is equal to rf sine 90, that is tau is equal to rf, and this is the point we will be getting what? Maximum torque. And that's why in the door the handle is placed at this point. So whenever you are applying a force in this direction or in opposite direction, in this direction, this is the position vector, right? And at this case the position vector and the force vector in that plane makes an angle 90 degree. So in this case torque will be maximum, so we can easily open the door. Now let's discuss about what is meant by couple. Okay, what is meant by couple? Simple example, this is a one object, say it as a one road. Okay, one road is here. One is applying a force in this direction, say it as force F vector. On the same body in this direction, the same force is acting on this body. What will happen to this body now? The body now it will start rotating, right? The body it will now start rotating. The forces are here equal, and the distance between these two ends or the point of application of force, that is these two ends, right? Say it as D. The couple or the torque of couple, we can say that the couple is equal to force into perpendicular distance. One of the force, both the forces are equal, right? So one of the force into the distance between the two forces, and that is represented here about D, and this is the simple formula we are using for what? Couple. Simple example, if you consider, if you try to open a cap of a bottle, okay, cap of a bottle, when you how you can open the cap of the bottle? Using your fingers. So definitely you will be applying a force in this direction using finger. At the same time you will be applying a force in this direction also. The distance between these two forces, so this is force, this is also F, right? If this is F, this is also will be F. In that case this is the distance between the two forces, and here you can see there is a couple will be there. That means the body will or the cap will now start rotating. Okay, and this is simply called what? Couple. So what is meant by couple? Two equal unlike parallel forces whose lines of actions are different, it constitute a couple. Once again, two equal unlike parallel forces whose lines of actions are different are constitute a couple. So I hope you understood this topic, what is meant by torque and what is meant by couple. Thank you all of you.